Welcome to Operations with Radical Expressions. Let's get started. Our essential question is, how do we add, subtract, and multiply radical expressions? Remember that an equation is a mathematical sentence that has an equal sign. So this is telling you that 3x plus 1 is equal to 5. So this would be an equation. Whereas an expression is just a mathematical phrase like this, 3x plus 1. So this would be an expression. There is no equal sign. So you can see an equation has two expressions together, whereas an expression never has an equal sign. All right, as a quick reminder, the steps for simplifying the expressions here, so we've done all of these before, adding binomials, expression plus expression is just combining your like terms, right? So here you'd have 7x minus 1. Whereas when you subtract your two expressions, you're going to distribute the negative, then combine your like terms. So you have to distribute the negative first, then combine your like terms. So here you'd have negative x minus 3. And when we're multiplying expressions, we're going to FOIL, or distribute, whatever you call it, then combine all your like terms. Okay, so if you notice, one of the big things about simplifying expressions is at some point you're always combining your like terms. All right, so now we're going to simplify radical expressions instead of just expressions. So when you add and subtract, we are doing the same thing as we did in the last slide. Adding is going to combine like terms, whereas subtracting is distributing your negative and then combining like terms. So let's go ahead and do that here. So if I'm adding, one of the things is we want to treat our radical like a variable. Okay, so that should help. Your radical you can treat like a variable when we're simplifying these expressions. So 2 radical 5 plus 7 radical 5. Combine our like terms, they both have the same radical 5, so we can just add 2 and 7, and we get 9 radical 5. Okay, same thing over here. I'm going to skip to this other adding one. I've got radical 2 and radical 2, so these are like terms, and then these are numbers, so they're like terms. So 3 radical 2 and 4 radical 2 is 7 radical 2. And negative 2 and positive 1 is negative 1. Now, if I'm subtracting, remember I have to distribute that negative. That's going to work more over here. Since there's not a parentheses, I don't have to distribute it. It just goes with the 6 third root of 5. So 3 third root 5 minus 6 third root 5. These are like terms because they have the same radical here. So I can just subtract my numbers. So 3 minus 6 is negative 3, and then I have the third root of 5 here. All right, so let's do this example. We're doing a radical minus a radical. We're doing our expression minus our expressions. We're going to distribute the negative. So negative 4 radical 2 minus 1. So my like terms would be 3 radical 2 and negative 4 radical 2, which is negative 1 radical 2, or you could just write negative radical 2. And then negative 2 and negative 1, which is negative 3. So be really careful, treat the radical like a variable, combine your like terms. If you're subtracting, remember to distribute that negative first, then combine your like terms. All right, so when we're multiplying radicals, if it's just a single radical times another single radical, if we're multiplying them, we can combine them together under the same radical. So this becomes radical 10. Same thing here. We've got 2 radical 5 and 3 radical 6, or square root 5, square root 6. They can go under the same radical because they're both square roots, just like up here. So I've got 5 times 6 because of what's under here. And then on the outside, 2 times 3 is 6. So now I end up with 6 radical 30. So that was 2 times 3 is 6, And then under the radical, 5 times 6 is 30. All right, so here's what I would say is the most challenging one. You know that here we would need to FOIL. Just like if this was an x, 3x minus 2, 4x plus 1, we would FOIL it. So that's the same thing we want to do here, is FOIL and then combine our like terms. So this just takes a little bit longer. So 3 square root 2 times 4 square root 2. And I'm actually going to write out what we just did here. So we did this times this. And this becomes 3 times 4 is 12. And then we multiply 2 times 2 under that radical, which is 4. Now let's do the next term. 3 square root 2 times 1 times a 1 is just 3 square root 2. Now let's go to the next terms up here. Negative 2 times 4 square root 2. So we've got negative 2 times 4, which is negative 8, and then we still have this square root 2. And then the final terms, the last two terms, we have negative 2 times 1, which is just negative 2. Now we want to look back and let's check and make sure none of these can be simplified anymore. And what I mean by that is the 12 square root 4, square root of 4 we know, it's 2. So 12 times 2 is 24. So now we have all of our terms. And these actually, square root 2 doesn't go down anymore. So if you happen to end up with something like this, square root of 4, that you can take the square root of, do that. But otherwise, leave them as they are. So now we can go back and combine our like terms. We've got a 24 and a negative 2, so that's a number we can combine, and that's 22. And we have 3 square root 2 minus 8 square root 2. And remember, since we're subtracting them, we're combining our like terms, that becomes negative 5 square root 2. So when we FOIL these, we get 22 minus 5 square root 2. So if that confused you, go ahead and go back and rewatch to see how we multiplied all 4 terms together and then simplified to get this answer. Don't forget to write your summary and your questions, and make sure you understand the basics of this video before you come to class. Thank you. Bye.